Here our topic is rheology. Rheho plus logy. Rheho means flow, and logy means like study of science or something. If we talk about its mean, it is a branch of science in which we study about the flow. Or in another words, we can say it is a defined as a science of flow and a deformation of material under the influence of stress. And if we talk about their uses, they are manufacturing of dosage form, mixing and flow of material, and also a packaging. And if we talk about their types, there are only two types, Newtonian and non-Newtonian. Non-Newtonians are like pseudoplastic, plastic, and third one is dilatal.
A Newtonian fluid is defined as one with constant viscosity, with zero shear rate at zero shear stress. This law states that the shear stress in flowing fluid is directly proportional to the rate of shear. Shear rate. Shear stress are stress. Examples of Newtonian fluids: water, alcohol, mineral oil, gasoline. Newton's law of flow. Newton's law of flow states that the shear stress between adjacent fluid layers is proportional to the velocity gradient between two layers or shear rate, mathematically, to dv.er, tau asequai ansai, dv.er, where ita is constant, which is coefficient of viscosity or dynamic. Viscosity. Tis shear stress. dv.dr is rate of shear. Rate of shear is defined as change in velocity dv between two planes of liquid which is separated by distance, dr. Shear strain dv dr, shear stress tau, is the ratio of shear force to cross-sectional area, FIA, required to bring the flow. Viscosity or dynamic viscosity, N, is defined as resistance provided to a layer of liquid when it moves over another layer of liquid. Let it explains by diagram. Fixed surface over which the fluid is following. The distance between two layers is denoted by R. The layer of liquid which is in contact with fixed surface, they have zero velocity. Dynamic viscosity divided by shear rate. S shear stress, F dV FA, where N is the coefficient of viscosity, or simply viscosity, or absolute viscosity, or dynamic viscosity. FGG, kinematic viscosity. Kinematic viscosity. It is defined as the ratio of dynamic viscosity, N, to the density, P, of the fluid. Kinetics of viscosity, V, P. The SI unit of kinematic viscosity is m22s, and CGS unit is Stokes or centistokes. It is a measure of the resistive flow of the fluids under influence gravity. Effect of temperature on viscosity. Viscosity of a gas increases with the increase of temperature. Viscosity of liquid decreases as the temperature is raised. The fluidity of a liquid increases with temperature.
So in non-Newtonian system, basically these are those liquid or fluid which do not follow Newton law of flow, in which shear stress and rate of shear is not constant. Secondly, viscosity is not constant. Example, emulsion, gel, ointment, etc. So basically these are of three type: plastic, pseudoplastic and dilatant.
Plastic flow. Those material substances flow plastic flow are called Bingham bodies. In this flow, when we apply shear stress, initially there are no change in shear stress until shear stress reach yield value. Yield value. The amount of shear stress are required to break the floccules is called yield value. It is denoted by F. Yield value, they follow Newton law of flow. Mathematically, F is equal to shearing stress, G is equal to rate of shear, H is equal to viscosity, F is equal to yield value. According to Newton law, shear stress into rate of shear, F minus F into G, F minus F into UG, U is equal to F minus F upon G. Mu is equal to plastic viscosity. Example flocculatory system, suspension of zinc oxide in mineral oil, etc.
Second, pseudoplastic flow. It is also known as shear thinning system. In this, viscosity decrease when we increase the shear stress. There are also change in rate of shear but not linear. For example, polymer and gum and ketchup also. So you can see that when we plot a graph, a bend line will be formed. It indicates that viscosity decrease when we increase the shear stress. To know more about it, I have added the video at the last where you can see the example of the pseudoplastic flow. And third, dilatant flow. Those fluid in which viscosity increase when we increase the shear stress. In this, the material returns to its states of fluidity when the shear is removed. For example, cornstarch in water. As you can see the graph, the line moves upwards. It indicates that viscosity increase when we increase the shear stress. And here are the example of the pseudoplastic flow and dilatant flow.